Welcome everyone to Analytical Use Cases with AWS Database Migration Service. My name is Joan Winford. I'm a Senior Manager with AWS. I currently lead something called the Database Freedom Program, but prior to that I was the launch manager behind AWS DMS 5 years ago. Joining me today we have Riaz, who's an SDE on the DMS team, so he's one of the guys that's actually developing the products behind the scenes, and Abhinav, who is a database engineer and who knows all things about the inner workings of the product and how to get it to work with your given solutions. Now I'm glad to see everyone's still here. It's good, you know, sorry, deal with the clapping for a sec. Glad to see everyone's still here. You know, it's the last full day of reInvent, and I'm sure everyone's all excited and looking forward to the replay party, which really, you know, that's probably why you're kicking around, right? But no, seriously, we'll be talking about some useful things about how you can leverage DMS to help with analytical use cases. As an overview, what are we going to talk about? Well, before we dive into exactly how you can use the technology, we're going to speak about some of the analytic solutions that we offer at AWS. They're not, you know, the only solutions out there in the marketplace, but we think they're great ways that you can leverage the functionality that DMS offers and, you know, use them for reporting or analysis purposes. Of course, once we've talked about those analytic solutions, I'm going to have Riaz take over and tell you a little bit more about DMS, how it operates, what it does, what are the data sources it works with, and, you know, just what's happening behind the scenes as you're using it to feed data from various different sources into, you know, an analytical solution. Now, I understand that reInvent is filled with lots of PowerPoints. You guys have probably seen more PowerPoints in the last few days than you would traditionally see in the rest of the year together. And to that end, we're going to spend a full third of the time today actually doing a live demo, showing you how to use the product and you know what some of the possible results are. AWS has a very large suite of analytic solutions. We're of course not going to be able to talk about and demo every one of them today, but you know, at least we'll give you a bit of a taste. And as with everything, of course, you can go home and try it yourself. Related breakouts. Now, you know, for a little bit of trivia, we have to prepare our slide decks well in advance of when we even know what the schedule is going to be. So when this slide was prepared, we didn't know which order sessions we're going to be running. So hopefully some of these related breakouts, if they're of interest to you, are still available to go see. Some of them may have already run, but you know, just good to take note of. And if you're interested in learning a little bit more about a specific migration scenario, you can of course go check out these related breakouts if they are still available. All right, so as I mentioned, we're going to kick off with a bit of an analytics overview. What are the different analytics solutions that we offer at AWS? But before we go into the actual solutions, why don't we talk about why, right? You need to understand what the basis is and how things are changing in the industry before you look at what's the best analytics solution for you to use. We're seeing three main trends in data right now. There's an explosion of data, microservices are coming along, and you've got a DevOps model change that's come through, you know, from the standard method of IT operations. If we dive a bit more into each of those, the explosion of data, what's happening is you've got a lot of data that's coming from a lot of different sources that you didn't have before. Generally speaking, it's coming from network-connected devices. Take, for example, right now, in everyone's pocket, you're going to have a mobile phone, right? There's a lot of data coming from that. You probably have a lot of you would have a wearable device of some sort to track your steps, and no doubt this week you're getting a very high count on that step count and, you know, meeting your fitness goals well and truly. But there's other things too. Every smart device produces this real-time data. You've got not only those mobile phones, but you've got connected cars. Bit of trivia there, apparently 1/3 of all new cellular network connections these days are actually from cars, not standard mobile devices, if you will. You've got smart homes, wearable technologies, security systems, manufacturing equipment, you know, right down to things like your fridge has a screen on it these days that is, you know, not possibly, it is going to be connected back to the internet. And all of this is generating a huge amount of data. Outside of just the pure devices, it's sometimes the apps on the devices. You know, all of these social media things like, you know, your Facebooks and your Instagrams and what have you. You know, as we all know, they're not giving them away for free. They're using all the data behind the scenes and feeding them back to essentially large data and analytic systems to use. By our estimates, we think the data grows about 10 times every 5 years. So large growth of data. So we know data is growing. There's lots of it. What are other things that are impacting it? Well, microservices are changing the data and analytics requirements. Organizations are moving from the development of giant monolithic applications into a microservice app. Basically, what this allows an organization to do is break down a complex problem into independent units so that a developer can operate on a small piece and come up with the best solution for that particular problem. This allows people to iterate, respond more quickly to challenges, and overall move faster. But what it does mean is you've got developers picking the best solution for their problem. It sounds like a good thing, but it does mean there's all sorts of different data types out there. And secondly, it also increases the need for real-time monitoring and analytics on these different components to be able to respond to any issues or to respond to, say, things like changing customer preferences. All of this affects the analytic solution that you're probably going to use and drives the need for things like streaming from DMS into those analytic solutions. And last but not least, this rapid rate of change driven by DevOps. You've got things like developers deploying in a continuous development model, automated deployments of software, all different pieces coming together in a very fast rate of change to be able to respond quickly to business needs. What it means, of course, is that you need to monitor all of these changes and take actions as appropriate. There's no point in having a continuous development stream if something breaks and nobody notices, right? So that's where the analytic needs come in. So if you're building new apps in the cloud, obviously you know a one-size-fits-all solution is not what you do anymore, right? You're not going to use a standard relational database for every possible app that you have in the cloud. Traditionally, your ERP and your CRM systems, yeah, you needed ACID compliance, relational database, kind of made sense. You had to log those transactions, and at most, that data probably grew into the gigabytes, and on very rare occasions got into the terabytes. Now, new applications have social, mobile, IoT, and have global access requirements and can generate data into the petabytes of size on a fairly regular basis. On top of all of that, they need to be able to access the data with millisecond latency pretty much anywhere in the world. Take, for example, we were using the wearable fitness trackers, right? Those are spread around the world. They're not going to all be feeding the data back into one central database in, Virginia. They're going to be spreading it out to what makes regional sense, but you're still going to need to do analysis in some sort of centralized way in a data warehouse. So these are just all things that are changing, and actually it's important to note that the data is not always in a structured format like it is with a relational database. You could have data coming in JSON format, you could have open formats, Parquet is another common one, and it doesn't make sense to have to cleanse it all to bring it in. You want to be able to interact with it in a way that makes the most sense for the given use case. To enable all of this for customers, AWS provides the broadest and deepest portfolio of services compared to any other cloud vendor. Many of them are named above, and they kind of align, as you can see in the chart, to the general service that they provide. AWS offers at least 10 data movement services, 13 analytics services, 18 machine learning and AI services, and 17 security and governance services. Now you'll notice I prefaced that with at least. Well, as we all know this week, those numbers have all changed, and there's going to be more and more generally specific services to address any possible use case out there. As I mentioned, we're not going to be able to talk about every analytics service today. That's just plainly put unrealistic. But I'm going to talk about a few key ones before Riaz jumps into and talks about the use of DMS. We can't really talk about analytics without first talking about Amazon Redshift. Amazon Redshift is our fast and scalable data warehouse. Essentially, we're making it cost-effective to analyze all of your data across your data warehouse and data lakes. Redshift delivers 10 times the performance when compared to a traditional data warehouse by using machine learning, massively parallel query execution, and columnar storage. All of it on top of course, a very high-performance disk. You can set up and deploy the new data warehouse in minutes. You can run queries across petabytes of data, and you can also run it across exabytes of data that you might have in a data lake outside of the data warehouse. And generally speaking, that data lake in Amazon terms would be built on top of S3. Most results come back in seconds. With Amazon Redshift, you can start small. 25 cents an hour seems pretty reasonable to me. There's no commitments, of course, because with everything in cloud, you scale up and scale down as required, and you can scale out to petabytes of data for a cost of roughly $1,000 per terabyte per year. That's about 1/10 the cost of a traditional solution. Customers such as Vivo, Yelp, Edmunds, Hilton, Dow Jones, and Equinox all use Redshift because of these following benefits. Fast, right? I said it was 10 times the performance. Essentially, we're using machine learning to adapt to the analytical workloads as required, and we optimize the cluster to provide the fastest query performance as things are being processed, using parallel processing to give you very quick results. Unlimited scale. Look, Redshift, in essence, can scale up and scale down in minutes. We can expand compute power automatically. We can expand disk. It just basically takes the human factor out of the equation to basically be able to respond in a quick and scalable manner. If I take an example that for us is very close to home, Amazon.com, the retail side of the business. We used to manage all of our databases in-house in a fairly traditional way. You can't blame us for that. Amazon.com launched back in the 1990s, and you didn't have a whole lot in the way of solutions then. But as time went on, we found we were spending more and more time on database administration and maintenance. As everyone's aware, we have 2 very big shopping days each year. One of them we just went through, the Black Friday, and then of course we also have Prime Day. Generally speaking, to get ready for these days, we had to start our planning 6 months in advance and estimate how busy we thought things would be. We'd have to go acquire the hardware, we'd have to install the operating system, of course install the databases, make sure if you had to shard them to be able to handle the scale, that was all done, and of course the DRHA stuff that comes along with it. All of it was a huge amount of expenditure and time, both in terms of hardware costs and manual labor. And now, of course, Amazon has transitioned to AWS native services, one of which is Redshift. We, of course, use other things like Dynamo and Aurora behind the scenes as well, but it allows us to deal with those peak loads that we need to without huge amounts of forecasting and effort. And as everyone just saw, we just went through Cyber Monday, biggest shopping day ever, no hiccups. So we're using things like Redshift behind the scenes to be able to handle that. On top of this, of course, Redshift, you can also extend it to your data lake. So if you have a bunch of unstructured data in your data lake on S3, Redshift Spectrum can help analyze that. And just this week, we announced Redshift Federated Query. That's what it is. I had to remember the name. And that allows you to query data in a traditional relational database as well. So why would you want to do that? Well, it saves you doing a bunch of ETL. So if you just have bits and pieces of data that's on relational systems, with Federated Query, you can pull all of that information into a single Redshift query without having an ETL process that's populated in there. Doesn't necessarily make sense if you have large data sets and you need to transform it in some way, shape, or form, but it's a neat feature that's just, again, giving you flexibility and trying to give you the option to address whatever business need you may have. The next service is Amazon Kinesis. Kinesis family consists of 4 core services for data streaming and a 5th service, Kinesis Video Streaming, to enable our customers to stream and analyze video and audio in real time. So these 4 core services, you've got Kinesis Data Streams, which is the standard one, if you will, to enable customers to capture and store data. You've got Data Analytics to allow customers to build real-time applications in SQL or Java. We've got Kinesis Data Firehose, which loads data into streams, data lakes, or warehouses in a cost-effective way of doing large volumes of ETL. And then you've got Managed Streaming for Kafka, which is a managed service for Apache Kafka, very common framework for data streaming in the industry. Next up is Amazon Elasticsearch. Elasticsearch is easy to deploy, operate, and scale Elasticsearch. This was a fairly common move for Amazon. We believe in giving you the ability to differentiate your business. What do I mean by that? Well, anybody can operate a database, or anybody can operate, a streaming search, but that's not really what makes your business unique. It's how you use these things and how you build your particular product for your end customers that makes unique. So Amazon Elasticsearch is just one example of this. It's a managed search streaming service. So you don't need to worry about handling it. Let us do it. You use the results in a way that can help differentiate your business from the competitors. Same deal goes for things like RDS or many of the other managed services that Amazon offers. To give you an example of a way you could use this, Adobe uses Elasticsearch service to cost-effectively analyze and visualize large amounts of log data for the developer platform. Their developer platform, the last figure I received on it, peaks at over 200,000 API calls per second. With Elasticsearch service, Adobe is able to easily see the traffic patterns and take action on any problematic areas or identify trends for things that they may need to improve in the future. And they're doing this all, of course, with reduced operational overhead. Then we get to Athena. I think Athena is a great service. If you haven't looked at it before, I highly suggest you do. My background, I used to work with a lot of people in the accounting industry, and great bunch of people. I'm not gonna fault them at all, but they do love to keep everything, right? If you couldn't convince them to throw away that ledger transaction from 1985. They'd feel they need it. What Athena lets you do though is query against data that's stored in S3. So if you're migrating a data set that has a lot of historical information, you could of course put it in something like Amazon Aurora. Amazon Aurora currently scales up to 64 terabytes, and it's probably going to grow even further soon. But what Athena lets you do is, instead of putting that data in, let's just call it slightly more expensive storage. Obviously, storing data in Amazon services is never that expensive, but there's different tiers, right? It costs more money to store data in an online database than it does in S3. So Athena lets you take that old data, that historical data that you probably never need or rarely need, and put it in S3 for storage. And Athena lets you query that data essentially using an SQL statement. So a great example is you can take out all that old data, put it there, and store it for very, very minimal amounts. Generally speaking, about as little as $1 per terabyte per month. You can put it in S3 or S3 Glacier or S3 Glacier Deep Archive even. And on top of all that, Athena, much like Redshift, now allows you to run SQL queries across relational, non-relational, and custom data sources, giving you the ability to do federated queries for that time you need to consolidate information from different sources. So we've talked a lot about different analytics solutions, places where you can put your data. Well, what do you do with that data once you put it there? Amazon's answer to that is QuickSight, right? So what is the idea behind QuickSight? Well, traditional BI solutions required, the usual client-server type architecture. You probably had to commit to saying, all right, I'm going to have 25 readers and 5 report creators, and sign on the bottom line for some 3-year commitment and tens of thousands of dollars. That's your traditional vendor method of selling BI solutions. QuickSight doesn't work that way. It's fully serverless. No need to set things up, no need to install anything. You can give it to tens of users, thousands of users, or even hundreds of thousands of users. The pricing is designed to give you the ability to deploy it to everyone without breaking the bank. Of course, there's a notion of readers, as is fairly common in this space. But the thing is, these readers are charged at a very minimal amount. It's 30 cents for a 30-minute session, capped at $5 a month per user. Now that's less than what it probably costs you to provide coffee to your end users. So very, very affordable there. And an author, the people that actually create the reports, that costs $18 per month per author. Again, overall, when you compare it to the cost of your traditional BI solution, this is very, very affordable. And of course, it goes without saying that this fully integrates to all of the Amazon solutions, whether your data is sitting in S3, data warehouse like Redshift, or in a database like RDS or Aurora. Essentially, we've made it very quick, very affordable, and very flexible. QuickSight was launched back in 2016. We've added a lot of new features since then. If you haven't checked it out since that time, I definitely suggest you go back and take a look. But later today, Abhinav is going to show you QuickSight in action, so you can see some of the features yourself as he progresses through. That's it for the analytics overview. I'm going to pass you off to Riaz, who's going to show you a little bit more about DMS, what it can do, and how it hooks into all of this stuff about analytics. So Riaz, okay, all yours.
Right. Thanks, John. This was a very good overview of analytics services that are available with AWS. Hello everybody, myself Priyash Sirguppi. I am working as a senior SD at DMS Database Migration Service. So I work on this core technology that allows you to migrate / replicate your data or data records from your source database to any of this target database. We'll start with overview of database migration service in general, how we get here, what are various product highlights, which are the supported sources, target, and what are all the things we are doing, and we'll discuss couple of customer example, and then we'll deep dive into analytic use cases and how the services that are described by John, actually how you can use DMS to perform the analytics. So let's get started. So little bit on the background or history of our database migration service and how do we get here. So if you see at AWS, we have this neat product which allows you basically to run your different databases on EC2 or on services like RDS or as a purpose built database services like Amazon DynamoDB, Amazon Neptune. These all look good. Now at AWS, if you see earlier adapters were the startups which use AWS to quickly incubate their ideas, and that allow them to scale up, scale down easily. But now what about these big enterprises? Enterprises who are running their workload, who are their on-premise data centers, they are running their workloads for decades. For them, migration to the cloud or getting into this new technology was not that easy. Because if you think of migrating your workload or migration of data center, that involves a lot of things like apart from financial, budget, planning, educating the DBAs, worrying about the conversions, migrating various apps. Now at AWS we listen to this customer. Customer asked us to make this migration easy. They also wanted to make it less intrusive, and they wanted to have the ability to minimal or near zero downtime during this migration or replication. They also wanted to have the ability to migrate to this heterogeneous databases, the new databases which are purposeful built for specific use cases. They also wanted, like after migration, an ability to replicate data continuously so that you can keep your data in sync with the target. With all these things in mind, we designed this database migration service, and our goal is to allow customer freedom to choose the base platform for their need, that is #DBFreedom. And as a part of it, we have basically two solutions, an AWS schema conversion tool and AWS database migration service. Schema conversion tool takes care of basically conversion of schema from your database, data warehouse to this cloud native databases that are available. And DMS basically take care of migration of data from on-premise to cloud. We design it to be so simple that your replication instance is available in less than 10 minutes. And we also design it so that it will be less intrusive and as well as meets the requirement of near zero downtime. So far we will go over the list of supported targets which are possible, but this is like a replication / migration Swiss Army knife, where you can migrate data from any of the source that is supported to any of the target which we are supporting. So far we have been pretty successful with more than 205,000 migration done so far and continuing. Alright, so we'll start little bit deep dive on schema conversion tool. When we are converting a schema or database from one type or one database to another database, where does really this conversion happen? And where does this magic of heterogeneous conversion happen? And there comes our SCT tool. This tool starts with assessment report. So SCT has a concept of this database storage object, database code object. So the storage objects are something like your tables, schemas, your primary keys, indexes, and code objects are your functions, store procedures, your views. Now assessment report basically specifies like these many are these storage object and code objects that can be automatically converted, and for the objects that cannot be converted, it specifies like, okay, these are the action items are required to convert it. So it guides you like what are the action steps you require to do manually to convert them to a different objects in the target database. Apart from conversion of this object, it also takes care of conversion of application code, and wherever there is a manual rewrite is required, it highlights the places in the code browser. Service substitution. Now there are some capabilities or features at the source database which might not be present at the target. Let us take an example where Oracle mail feature, which is very good for a database administrator, where you can get an email alerts for various schedules or various failures and lot of other things. Now this feature is not available with RDS Postgres. SCT tools helps here actually, where you can configure Lambda job, or it provides some Python library calls where you can emulate these kind of functionalities and make the behavior like what you have at the source side. It also help you with ETL modernization, where your existing jobs on-premise job and the ETL you can migrate to Amazon AWS Glue, which are compatible with Redshift. It also help you to migrate data to data warehouse, Amazon Redshift solution using SCT has data extractor agent, which extract data from your source data warehouse and help you migrate data to Amazon Redshift. With Redshift, it has additional functionality where you can optimize schema. So it provides a way to basically specify some strategy and rule, where strategy could be use metadata information or use statistical information to perform some optimization, or rules could be like you can use a partition key or distribution key to perform basically to optimize your schemas on Redshift. So these are high level highlights for SCT. So as we discussed, this is multifaceted tool where it guides you from assessment, planning, actual conversion of schema, migration, and overall optimization of migration process. With assessment and planning, as we have seen, it provides this assessment report where it specified like which are the action items which you have to take to convert data or those objects from source to target. And it also help you like these are this much is the complexity of effort required to convert your application code. I would like to give an example of one of our customer, Trimble, how they use SCT. So for Trimble, they have a requirement, they wanted to migrate their data from Oracle to AWS cloud, and they were exploring possible option. So SCT helped them to find something called as a distance of their Oracle setup with the setup or options that are available at AWS side. And with the SCT, it helped them to find out that there is a less gap with RDS Postgres. If they migrate their Oracle to RDS Postgres, there are minimal effort required or minimal complexities involved with the conversion of data types, and they use RDS Postgres as their target database. In fact, like there were some, they have some set of functionalities like reporting, OLTP. With the SCT tool, they could plan their resourcing, and that helped them to reduce migration effort. Now coming back, like SCT help not just with the planning, but it also does actual conversion of schema and your code, where you can set up your source and target engines, and within few clicks basically like the schema which is present at the source is available or in a converted form available at the target. It also help you to migrate data to data warehouse and optimize entire migration process. So this is the list of supported sources and target that are available with SCT and DMS. Now if you see, like it covers various verticals of the data from relational, NoSQL, data lake, data warehouse. So basically we support like 12 different sources and 14 different targets, and DMS is able to migrate data from any of the supported source to any of the supported target. For data warehouses, actually we have SCT data extractor, which runs at your data warehouse and basically extract the data and help you push to Amazon Redshift. We will discuss couple of example Like one of the example could be homogeneous migration, where XPDI is using DMS to migrate from on-premise MySQL to Aurora MySQL. Or at heterogeneous side, Verizon is using this DMS to migrate from Oracle and Microsoft SQL to Amazon Aurora. You can also migrate from NoSQL to NoSQL, like MongoDB to DocDB. Even from NoSQL to SQL, like you can migrate from MongoDB to any of the supported targets that are listed here. Using SCT, you can extract data from Cassandra, push to S3, and once it is available on S3, you can migrate data to all supported target by DMS. DMS also provide integration with AWS Snowball, and in next slide we'll see more details into it. In this list, you also see Amazon Elasticsearch service, which is a full text search engine. Now, this is more of a replication use case where you have data that is residing in your relational target and which might not be text searchable. So, you can use DMS to move or copy the data to Elasticsearch service and use it for search related applications. You can also stream your data to Amazon Kinesis data streams and do different kind of analytics. So, in the next part of this session, we will look into detail how we can use Kinesis to perform data analytics. So, these are product highlight for our DMS solution. So, security is one of the key area that is key focus area that is discussed these days. At DMS, we support all security certifications like HIPAA, OSI, PCI, and also like any data that is used by any customer data that is used by replication instance, which is stored on the EBS and that is encrypted. This encryption is done using AWS Key Management Service, which is unique to your account. Also, we support this secure socket layer. At monitoring side, we provide various CloudWatch metric that help you to track status of your migration. You can basically track how much of data is currently migrated, how many records are done, how many tables are migrated. You can also basically get insight on health of your replication instance. For example, CPU utilization, whether instance, how the instance storage is doing, and you can set up alarms which will help you to alert to detect any problem in advance. It is also possible to access migration logs, where you can set up CloudWatch log account and you can access database migration logs for debugging of any issues. We also provide a feature called as a pre-flight, which help you to assess your database migration. You can, before actual migration, you can run pre-flight tests that are run on your setup, and which will help you to detect if there is any problem with the setup. For example, you can run this test and you are migrating, let's say, thousands of tables from source to target, and there are some tables which has some custom columns which are not supported at the target. With the pre-flight test, you can detect this situation in advance and take action. As we discussed, we support this Kinesis target, which help you to stream data to cloud, and once it is available, you can use this stream data for monitoring, for IoT, mobile, or for various kinds of analytical use cases. We also provide a validation feature which basically checks the data at the source if it matches with the data at the target, and this is not just for homogeneous migration, even for heterogeneous migration which goes through various type of data convergence, we support the validation. Considering cost part, so with all these features, we don't charge you based on the source you have, or based on the location of the source or target, or based on what is source or target. We also don't charge you based on how much amount of data that is currently migrated. The cost is only based on the replication instance that is used for the migration. So that way, this is the low cost solution for the migration. As we discussed, DMS also provide integration with Snowball Edge and S3. So you have this Snowball Edge device, you take to your on-premise, and using SCT agent, you basically upload your data from your on-premise databases to the Snowball Edge device. Snowball Edge device is shipped to AWS, where it is uploaded, the data from the Snowball Edge device is uploaded to S3, and once it is available on S3, you can use it to migrate data to all the supported target that are mentioned for DMS. This way, you for a migration use cases, you have multiple options. Basically, you can fan in, fan out using DMS. So let's take a quick overview of how the migration works and how we are ensuring this near zero downtime. So this is a typical customer setup where there is an on-premise data center, and applications are running and they are accessing data from your on-premise. Now customer decides to migrate to AWS cloud, where you basically create a replication instance, start that replication instance inside your AWS account. After this, you establish a replication instance, you establish connection with the source and target databases. You provide basically all the security credentials that are required to connect to your on-premise data center, and as well as at the target side, whatever database you have selected, you provide the authentication and connection information. Once this is done, you select the tables, schemas, databases that you want to migrate. Here you can also, you don't need to load entire data from your on-premise to the cloud. You can basically perform a kind of filtering where you can selectively choose schemas or selectively out of those columns or in tables, or in fact given table you can basically select the columns which you want. You can do also metadata transformation, where you can do rename the tables or rename column in the process of migration. Once everything is done, you start the migration task and then let DMS load the data and keep them in sync. And after that, as per your convenience, during the low workload time, you can simply point to the new database that is in the cloud. Okay, so this was overview of DMS and supported sources. Now we'll go over like general use cases, how DMS is customers are using DMS for various scenarios. So as we have seen, with the near zero downtime ability, DMS can be used to migrate business critical application. It can also be used to migrate data from data warehouse to Redshift. Also, like you can use it to fan out, like let's say at the source database you have this single monolithic application which is used to store the data for reporting, for OLTP. You can use DMS basically to fan out to multiple services inside AWS cloud, where OLTP you can use Aurora, for reporting you can use Redshift. DMS can also be used to upgrade to major minor version. Let's say you migrate from Oracle to RDS Redshift 9. Now you can use DMS to even within the cloud to upgrade to Redshift 10 with the using the DMS migration ability. It is also possible to consolidate chart into Amazon Aurora, and you can get use of this massively parallel log-based storage that is available with Aurora. With DMS, you can archive your old data files on Amazon S3, and once they are available on S3, you can use it for analytics with Redshift Spectrum and Amazon Athena. This way, as we discuss with this list of supported sources and target, you can use DMS to migrate across SQL based and NoSQL based target sources and target combinations. At replication side, DMS is used to create cross-region read replica for backup and disaster recovery purpose. You can also run analytics in the cloud, and we will see those use cases in next slides. You can also combine data from heterogeneous data sources and hydrate your data lake, and you can use DMS to replicate data to streaming platform. So this was the general overview of database migration service. It's what are the use cases and how various customers are using DMS today. And with this, actually we will deep dive into DMS analytic use cases. So I would like to invite Abhinav Singh.
Thank you, John and Riaz. Hey guys, my name is Abhinav. I'm one of the engineers on the migration services team. I'm going to talk about how customers are using DMS for analytical purposes. I know the name takes you off the bit, like it's a migration tooling, database migration service. It doesn't quite fit how will it be able to do the analytics part, but yes, when the service started it was as a migration, but yes, it's evolving with regards to how we can do replication, or how you can do a data integration with regards to different sources and different targets that DMS supports today. So my intention is again not to talk more, basically give you a demo of how things are going to work. Before that, just going to go through a couple of examples. One of the examples is a couple of our customers are using today in the financial sector, in the life sciences, in e-commerce, and then we are going to go to a sample architecture with regards to what I have implemented here and how I'm using DMS, Aurora Database, Redshift, and QuickSight with regards to analyzing the data patterns with replication scenarios. So going ahead, this is one of the examples with regards to an architecture that a customer today is running and using DMS capabilities to do the analytics part with regards to Kinesis, S3, and using QuickSight. As you can see from the architecture, the first part is they have their database either in Aurora, or it's an example is an Aurora here. Of course, DMS supports 12 different sources and 14 different targets. So you can have Oracle, you can have SQL Server, you can have MySQL, you can have Postgres, whatever you like, which is supported in DMS, and you can use DMS replication capability to move the data from this databases to Amazon Kinesis. Now, the reason for Kinesis data streams here is the customer, with regards to replication scenario that DMS provides you, they are not just streaming data to Kinesis with regards to analyzing it with QuickSight, but at the same time, as a banking, as a financial institution or as an e-commerce institution, they are also trying to read the kind of transactions that are being happening on the database. Like for example, if I'm managing an e-commerce website, I would like to know if a customer put a product in the shopping cart but did not shop it. So what was the reason, and how many customers are like that who are putting a particular product but are not shopping it? So like trying to figure out if there was any hit or miss with regards to that, and at the same time, was there any issue with the web service itself? Was there an issue with the backend itself that they tried to shop something, but because of some issues on the backend on the database side, they were not able to go to the shopping cart or purchase the particular item. So using the Kinesis data stream analytics features, what they are doing is they are getting the data to Kinesis, and they are doing real-time streaming to understand what are the particular transactions that are being hit or that are being missed with regards to what is happening on the database. Now, DMS as a database migration service as a tooling just doesn't allow you to migrate or replicate everything. You have a filter capability also, so it totally depends on what you want to replicate or migrate. Like if you want to migrate just 2 tables or just couple of schemas, definitely you can, DMS will be able to do that. If you have, let's say if you are creating views, which is combination of multiple tables or custom queries, or if you have materialized views, DMS will be able to do that for you as well. So that's where this functionality is used by the customers to send the data to Kinesis. With regards to real-time streaming also, DMS has come along. Today if you are trying to do DMS replication to a Kinesis data stream, we are able to almost 20,000 TPS, we are able to handle that from a particular source database to Kinesis data streams with very minimal latency in DMS. So that's one of the key highlights. Now, going forward after that, what we are doing here is using the Firehose data streams. Customer is getting the data into a CSV format and loading into Amazon S3. It's the whole and sole purpose of loading data into S3 is not just because they want to read it using Athena, but it's also with regards to archiving purposes. With regard, like if I'm a financial sector, or if an e-commerce or life sciences, getting the customer data or getting the shopping patterns that are happening, I don't want to delete those. I want to archive it somewhere else so that I can run my machine learning algorithms, or I can basically feed some algorithms into that and get patterns out of it. So that's why it's stored in S3. S3 is a very optimized. I don't need a database to store it. Of course, you can go ahead and you can store it in a database also, but for an instance, you have to pay as you go or as you use it. S3 is a very cost optimized minimal storage abilities that is providing you. So that's where S3 comes into the picture. Now, customer is using Athena to query the data from S3. Now, the reason for Athena being used here is, as mentioned by John, Athena is an on-demand serverless capability that provides you dynamic querying based on your requirements. So, of course, if your requirement is a very real-time scenario, then using a database would definitely make sense. But if you are just generating a report like in the morning or after your business hour end, or based on certain timeline where you are generating the report, which is like an on-demand thing, then you don't need a particular instance to be provisioned all the time where you are running these queries and getting the insights out of it. So that's where Amazon Athena is being used, because of its serverless capability and because of its durability and availability, which is 99.9999%, and that's where Athena is being used here. Now, using Athena, we are now feeding data to Amazon QuickSight, and then we are trying to analyze things. So that's where one of the examples that you can see on this screen is how the query how Athena is being queried. QuickSight is getting the data, and basically you can have a visualization like this. So this is just an example with regards to one of the scenarios that I explained. Going on to the next one, this is what I'm going to show you hands-on as well, where as you can see on the screen, what we are trying to do here is, let's say I am a sporting event organizer, and of course I have different departments, like a department which is responsible for ticketing, a department which is responsible for organizing those events, a department which is responsible for advertising. So different departments of course will have their different requirements, and then their different tooling or applications that they might be using, right? So here that's where we have highlighted that since DMS supports a variety of sources, that's where today, as a sporting organizer, my MySQL database is hosting the sporting events data, and my Postgres database is hosting my ticketing sales event. Now, in order to understand what is the relation between these two organizations, or what is the relation between with regards to how should I target my advertising with regards to sporting events, or how should I increase my sales in a particular region, that's where I'm using DMS real-time capability to replicate data to Redshift. Now, the reason I'm going to Redshift is because I want to store this data not just for a data warehousing capability, but also with regards to understanding how I can change this data, or how I can have on-demand querying on the same, because my use case here is to have real-time reporting generated via a database, and that is the reason Redshift is being used. You can definitely use S3 also based on the use case, based on your SLA requirements, but since I'm using Redshift, as I'm feeding data into my source database, as someone is buying a ticket, my MySQL database is getting updated, it is getting fed into Redshift, and accordingly QuickSight is also getting updated, and I can see the patterns, how it goes while the event is happening, or what is the pattern during Thanksgiving if an event is organized, or what is the sporting, how things are going if there are sporting events in New Jersey or New York. So that's what we are going to talk more about, how I have implemented this. Just to go before the demo, he is one of my favorite pop singers, and it actually makes sense, where if you know technology, which is actually good, but if you cannot use it, it's useless. So moving forward with regards to the demo part, and thanks a lot for not sleeping. So on the screen that you see here, that's basically the database migration tasks. So DMS has three major components. The first component is the EC2 instance that you provision. Okay, so whatever you see here is an instance of replication instance that you provision. So when you provision an instance, it's nothing but an EC2 instance which has a database migration service application installed in it, and that's what is being used with regards to replication. And that's where you can see the instance metrics with regards to CPU, freeable memory, IOPS, and everything, so that you know how the instance is in pressure when you are doing a real-time replication, and take measures accordingly if anything goes wrong. So this is the first part. Once you provision the replication instance, you go ahead and you create an endpoint like this. So what this is basically you are creating an interface in DMS where you are providing information like the endpoint information, the port, the username, password, the database, using which DMS is going to connect to your database, and basically then it will be able to fetch the data or it will be able to write the data. So that's where this is one of the endpoints that I have created to connect to my databases. Once you are done with the database, you go ahead and you create a task. A task basically is nothing but you make sure that DMS is now connecting to your source. In my case, it's MySQL, and my target is Redshift. So that's where what this task is doing is connect my source. It's going to fetch data from my source and send it on to the target. At the same time, you need to, when you are creating this task, you have the ability to define rules, like which tables you want to migrate or which schemas you want to migrate. Like for example, if I have to show you for this particular task, you will see all the basic configurations here, and at the same time, this is these rules that you see here, especially with regards to this. What this basically means is I'm trying to migrate all the data that is present in that schema from the MySQL side. So that's where if you want, you can specify a table name. If you want to filter out within the table with regards to a particular column or a condition, you can also specify that. So that's where DMS offers those filter capability also. Once you are done, once you have created the task, you go ahead and you run the task, right? So this status that you see here, right? The status that you see here, what this basically means is load has completed. Basically all the data that is present in my table, like let's say 100 rows or 1000 rows, everything has moved onto the target, and now I have started my ongoing replication, which means as the changes are happening on the source, database migration service is capturing those changes and sending on to the target. To give you better idea of how it will look like, as you can see from the first row, what this means is the inserts part basically means that on my source, after the full load completed, I did 713 inserts, and 713 is a part of the change replication that is happening right now. So that's where this table was completely empty. So the full load rows you see is at 0. Basically that means the table initially was having no rows, but in replication phase I inserted 700 records, and now it has replicated that. So it gives you that amount of visibility also with regards to how many records it is moving in the full load part, as well as in the CDC part also, where you can see this is the full load part, and these are the counters with regards to CDC, like 713 here as well. So this is what. And then we also provide a rich set of CloudWatch metrics integration also, where especially these two metrics that you see here, CDC latency source and CDC latency target, they basically also tell you how far behind DMS is in replication with regards to moving the data between the source to target. So of course in real-time replication scenarios you would want the latency between the difference between the source and target to be minimal, and that's where these metrics give you an idea of how DMS is performing. Like from this graph, my current latency was 2.7 seconds. So that means my target was 2.7 seconds behind my source when I started inserting the records. So that's where it also gives you that rich set of functionality which you can create alarms on. You can get notified how your replication is doing in terms of your business critical application replication. Once I am done with this, I have already my data into Redshift cluster. I have already pumped all my data, and replication is ongoing. So I am just going to go to QuickSight. So in QuickSight, as you can see, I already have created my data set. But just to give an introduction, what you do is, if you are opening QuickSight for the first time, it will give you a sample first 4 analytics, which will basically help you understand how QuickSight actually works. You can definitely go and try that out. The new custom SQL script that you see here, that is basically me, where I have already created a report and I have saved it for this demo. And going forward, what you can also do is, you basically define the analysis, you create the data set. In the data set, I have already defined my data set, but once you click a new data set, it will give you this variety of options where you can connect. One quick thing is, if your QuickSight has been provisioned in the same account as your databases, like my QuickSight is running in the same account where I have my own Redshift cluster, so that it will be able to automatically auto discover, and it will automatically detect the clusters that I have and connect automatically. Or else you just need to feed in the data manually with regards to each and every part, and then QuickSight will be able to connect to that. So that's where using auto discovery or manual discovery, you can provide the data and make sure QuickSight connects to the same. Now going back to my analysis, with regards to this, once I am connected to my database, once I have all the tables that I need for my analysis, I am going to go ahead and basically create a new custom SQL. So the first option is, of course, you can select the tables that you know of, which you want to run analysis on. But what I have done here is, as a DBA, I know which tables are really important for me for the purpose that I'm trying to solve the problem for. So what I have done here is, I have gone ahead and have written a SQL query for the same, where I am just joining 4 or 5 tables to make sure I get all the information from that, and based on that I am getting this result on which I am running my analysis. So the first example of this is where once I have run the query from QuickSight to Redshift cluster, the first one is telling me this number of tickets by event date and event city. So as you can see the distribution here, if I point it on a particular date like July, it tells me which was the highest and which was the lowest in terms of the number of tickets sold. At the same time, I also have a graph which just to see an overall distribution of how much number of tickets are sold overall in this 2019 year for each and every city. I can see Texas is having more sales compared to New York. Maybe Texas has more events, or maybe the advertising initiative in New York is not that good. So that's what it tells me here. One of my favorites is this, which basically it is telling me what I'm trying to get here is what number of events are being organized in a particular city, and which city has the most expensive tickets. So as you can see here, that the distribution with regards to coloring is defining that which city is having most expensive tickets. Like as you can see, the stadium, AT&T Stadium, by event location, it is having the most expensive is $501 and the least expensive is $100. So based on the color code and the combination here, I am able to surmise that which city is going to be more expensive and where I need to reduce cost to get better analytics and better understanding of my sales. Last but not the least, everyone's favorite, pie chart. It looks good, tells you less information, but yeah. So with that, I'm almost done. Thank you very much for coming, and thank you very much for listening. It was really good to have you guys.
Thank you.